This tutorial we're going to be going over problem 1176 from Leetcode, diet plan performance. So this is a very good sliding window problem we're going to review. And just as a reminder, the 3 steps to solving a problem is 1, comprehending the problem, 2, visualizing it, and 3, implementing a solution. So as you can, just as first glance, you can see there's a lot of, mathematical speak going on here. So you want to try to distill this as quickly as you can. Starting from the first line, a dieter consumes calories on the ith day. All this is saying is that we're dealing with an array of data, and each point in the array is, a calorie number. So you see down here, 1, 2, 3, 4, 5, and we iterate over it. So now we iterate. So given integer k, so now we have another number. For every consecutive sequence of k days, for all 0, between 0, 1, and minus k, they look at t, the total calories consumed during that sequence of k days. What this is saying is that we have a number k, which becomes the window size, and we are, it's just a very basic, it's a mathematical way of just saying that this is a sliding window. So you have, for instance, if k is 2, you want to add up all the numbers within that window. So in this case, 1 plus 2 is 3, and they want to make sure that you're sliding the window one by one, just like this. And then the next piece is that there's now also a lower and upper integer. So if the sum of your sliding window is less than lower, then they perform poorly on their diet and lose 1 point. If t is higher, so if the sum of your window is greater than upper, they perform well on their diet and gained 1 point. And if they're in the middle, no change, there's 0 points. And finally, what we want to do is just return the total number of points the dieter has after dieting for calories.length day. So when you're done iterating over the array using your sliding window, just give me the final number of points. So, just looking at the first example, we already have it here. The sliding window is 1, so we're basically just iterating. So k is 1, lower is 3, upper is 3, so 1 is less than lower. So here I'm gonna, let's create a new array of our results. So 1, -1, because it's less than lower. 2, also -1, is less than lower. 3 is equal to lower, so we can just make 0. 4 is greater than upper, so 1 point. And 5 is also greater than upper, 1 point, so you add these up and you get 0. Let's look at the next example. 3, 2, window size is 2. So the sum of this, as you see here, is just 5. Lower is 0, upper is 1. 5 is greater than 1, so output is 1. And final example. Window size is 2. So looks like, let me just get rid of that. Output. So 6 plus 5 is 11. That is greater than upper, so 1. Let's move it to the right. 5 and 0, so the sum is 5. That is equal to upper, so no points gained there. And finally, 0 plus 0 is 0. That is less than lower, so -1. Add all these numbers up, and we get 0. So now that we've visualized what we're doing, let's start the same process but now actually writing code. So as a reminder, when the window size is 1, it's just a very basic iteration problem. We're just iterating and comparing. So let's just do only that. Let's just solve for this one situation. And the reason we want to do that is because all these problems are just iteration, but with the added complexity of example 2 and 3, we also have a sliding window. Okay. Okay, so we're going to start with a for loop. We're just iterating. I is less than calories.length. I plus plus. So just as we were doing in our previous examples of having an output, let's just create an array, an output that just stores the final result of each calculation, like are they below diet, in the middle, or above diet criteria. So let's see, let's const calorie equals, just to make it easier on ourselves. So if calorie is less than lower, output that push, so that's -1. Else if calorie is greater than upper, then that is 1. Otherwise they're in the middle and we want to push 0. So now we have so our array of -1s, 0s, and 1s, and let's just sum them all up. So we just use reducer. We have a sum that keeps track of all our numbers. We add each number, and we start with a base 0, and let's just run that with a very basic example. Sorry, let me get the basic example. So that is that lower is 3. Oh, k is 1. Lower is 3. Upper is 3. Okay, so we solved just for this example. And obviously this won't work for the other examples because we're not taking into account the sliding window. So let's look at what our sliding window is supposed to look like. 3, 2. We want this sum. So this action, like the first thing we do is we grab the sliding window. We create a window and we add up the values. So let's do exactly that. Let's create our window. Calories, the slice. We just want up to like k. So this will be 2. And then we just want to add up all the numbers that are in this range. And once again, we start with a default at 0. Okay, so we have our window, and now we don't want to iterate over each calorie. We want to compare the window against, is the window below lower? Is the window above upper? Or is it in the middle? And then, okay, so you know, let's just add a whole bunch of numbers here. And let's just, you know, for a moment imagine that our k size is 3. Like, well, what I'm trying to get at is we don't want to, like, okay, so a really basic solution would be to, like, you know, run the same function again each time that we run this. And now we just have, like, you know, a for loop within a for loop, terrible time complexity, and we don't need it. The reason for that is, look at this. So 3, 2, 4, we move the windows to the right. 2 and 4 stayed in place. Move it again to the right. 4 and 5 stayed in place from before. All we're doing is that we're getting rid of the leftmost number and we're adding the rightmost number. So 3 goes away, 5 gets added. Everything else stays in place. So why don't we just do that same exact thing, but in code, to create the optimal solution. So window minus equals our current number. So you know, we're already done with this calculation. So now we can like modify it. So window minus equals calories I, and then window plus equals calories I plus K. So that's going to be the next number. And you know, if you're astute, you probably already noticed that there is a case where this will create like not a number because it'll be out of bound. But at that point, we've already finished calculating our outputs, so it'll be fine. So let's run this with our examples, solve all the basic examples, and then submit, and we are good. So there you have it. Definitely give Code Visualizer a check so you can practice visualizing your sliding windows, and catch you later.